Here is a little mystery before we start. Imagine a single bacterium that divides into 2 every hour. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 4, and our lesson is all about laws of exponents. Before we start, a quick recap. In our last lesson, day 3, we studied decimal expansions, terminating and non-terminating recurring decimals. If any of that feels unclear, pause here and re-watch day 3 first, because today builds directly on it. By the end of this lesson, student understands exponents as compact multiplication and can logically derive the 6 laws instead of blindly memorizing them. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. Imagine a single bacterium that divides into 2 every hour. After 1 hour, there are 2. After 2 hours, 4. Then 8, 16, 32. In just one day, that single cell becomes nearly 17 million. Multiplication is too slow to write this down. We need a faster language. You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? Exponents are simply lazy mathematics. They are a shortcut for writing repeated multiplication. Because they are just a shortcut, the laws of exponents aren't new rules you have to memorize. They are just logical consequences of counting how many times a number is multiplying itself. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today, all 6 laws with intuitive proof and examples. In symbols, we write it as a to the power of m times a to the power of n equals a to the power of m plus n. Every word of that definition matters, so read it slowly. You already know multiplication, powers, rational numbers. This definition simply builds on those familiar ideas. Here is the key formula for laws of exponents. The formula is a to the power of m times a to the power of n equals a to the power of m plus n. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Why does x squared times x cubed equals x to the power of 5? Which means x times x times x times x times x. Which means x multiplied 5 times, which means x to the power of 5. What about x squared cubed? Which means x squared times x squared times x squared, which means x to the power of 2 plus 2 plus 2 equals x to the power of 6. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. The most common mistake on exams is multiplying the bases. Students see 2 cubed times 2 to the power of 4 and write 4 to the power of 7. We must explicitly show that the base stays exactly the same, because we are still just multiplying 2's together. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Simplify 3 squared, caret 4 times 3 cubed over 3 to the power of 7. Step 1, power rule, 3 squared, caret 4 equals 3 to the power of 8. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. Step 2, multiply 3 to the power of 8 times 3 cubed equals 3 to the power of 11. Step 3, divide frac 3 to the power of 11. 3 to the power of 7 equals 3 to the power of 11 minus 7 equals 3 to the power of 4 equals 81. How did you do? If you slipped anywhere, rewind and watch that step again, that is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits laws of exponents. We explored all 6 laws with intuitive proof and examples. The one formula to remember is a to the power of m times a to the power of n equals a to the power of m plus n. Watch out for the common trap we discussed. And remember our goal: student understands exponents as compact multiplication and can logically derive the 6 laws instead of blindly memorizing them. Next lesson: Introduction to Polynomials, Definition, Degree, Coefficients, Types. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.